I'm going to work through two of the homework questions. The first one is 6:13, which goes back to chapter 2 in summations. So it gives you this function, f of x equals negative 1/2 x minus 1 squared plus 7. And then the first question says, write the sum to find the area in the curve using left hand endpoint rectangles with a delta x or a width of 1. Be sure you set up your sum to include all of the factors. You don't need to calculate it. So for this, if we're doing left hand endpoint, we're going to start our domain. Oh, forgot to write our domain. For 1 is less than or equal to x, but less than or equal to 4. So if we were to draw this out on a number line, we got 1, 4, 2, 3, and we got 4 rectangles, x of 0, x of 1, x of 2. We're dealing with left endpoint, so here's your left. And our delta x is 1, so we're going to do this manually. We're going to literally just plug it in. So it'll be negative 1/2. And then we're going to put in, let's see. Well, before we plug this in, we need to get our x of k, which will be equal to delta x, so it'll be 1k plus 1. Our 1 is our delta x, and our 1, this is our starting value. That's our mx plus b. We're going to take this. We're going to throw it into here. So, should be, you guys should remember this somewhat. It'd be negative 1/2. 1k plus 1 minus 1 squared plus 7. And we're going to start with k equals 0. So you would literally plug it in there. And we would get, when we evaluate it, when k equals 0, my answer is 7. When k is equal to 1, my answer is 13/2. And then when my number is 2, 5. So you'd add all these up together and you get your total. Now, it doesn't have you calculate the total. Part B is writing the sum in sigma notation. So back to sigma, we're doing the left hand, so it starts with 0, goes to 2, negative 1/2, and then we plug it in, and we will get 1k squared plus 7, because these cancel. You're left with that. That should be your final answer, which I think is different than what they actually get in CPM. So I think their answer is wrong. Let's do 33. All right, 33. Crazy algebra. This will be fun. It's Frank. Frank's all over this. 2x cubed y squared minus 4x squared y squared plus 2xy squared all over 3xy cubed minus 3y cubed. Oh, what do you want to do for here first? It's got to be the GCF. So pull out all of your factors. So let's look for your GCF. We start with 2. Let's start at the top. So if we can pull out a 2 from each term, we can also pull out a maximum of 1x. So 2, an x, and then let's see how many y's we can pull out here. 2y, so y squared. Let's see what we got left. We'll have x squared minus 2x plus 1. Let's go to the bottom, do the same thing. Pull out your 3. We can't pull out an x, but we can pull out a y cubed. So we'll put out 3y cubed. And what we have left is x minus 1. Okay. To go farther with that, let's factor the inside. X minus 1, all over x minus 1. It's going to come out nice. Oops, can't forget about what's left here. 3y cubed. So we can cancel these. The y's cancel. I have 1 left on the bottom. So your final is 2x times x minus 1 all over 3y. I think that's as far as we can go on that one. Alright, let's look at b. b is x plus h squared minus x squared over h. You're definitely going to want to FOIL this out, so you get x squared plus 2xh plus h squared minus x squared all over h, and all of that trinomial is this guy FOILed out. So work out nice, cancel, cancel, and then in the top you're going to want to pull out your GCF again. So you pull out the h, you have left 2x plus 1 all over h. The reason we can do this is your h's now are gone, and we're missing the h. So we're missing the h there, so we're left with 2x plus h. Alright, factoring, using that GCF a lot in both examples. Alright, hope that helps.